Hi students, welcome to my YouTube channel. In this session, I want to discuss construction and working of Daniell cell. Daniell cell is an example of galvanic cell or voltaic cell. In the Daniell cell, we can convert electrical energy from the chemical energy. Because of a spontaneous redox reaction, chemical energy is converted into electrical energy. Actually, Daniell cell consists of two half cells. First one is oxidation half cell or anode, or it is a negative electrode, and second one is reduction half cell or cathode, it is a positive electrode. Which can act as a anode? Let us see here. Zinc rod dipped in aqueous ZnSO4 solution can act as a anode. Copper rod dipped in copper sulfate solution can act as a cathode, and it should be kept at a right side. Both ZnSO4 and CuSO4 solutions are connected with the help of U-shaped glass tube. A inverted U-shaped glass tube containing inert electrodes like KCl, KNO3 and ammonium nitrate. This kind of inert electrodes with agar-agar jelly, with agar-agar jelly like substance is known as salt bridge. Actually, this agar-agar jelly they will extract from the red algae. Actually, it is what you know, it is a unbranched polysaccharide having jelly like material, that is called agar-agar jelly. It mixed with the KCl, KNO3 and ammonium nitrate. They should be taken in the U-shaped glass tube, and the end of the glass tube is containing what? Cotton plug. To prevent the mixing of solutions, what we are using to prevent the diffusion, we are using cotton plug. Now, actually at the anode, this is the reaction going to take place. At anode, this reaction is going to take place. At anode, zinc metal has more tendency to lose the electrons, and it can produce Zn+2 and 2 electrons. And you know that the loss of electron is known as oxidation. At anode, oxidation takes place. Because of oxidation, the electron density increases, electron density increases at the anode. That's why it is represented with a negative sign, and it is called as negative electrode. Next, at cathode, this is the reaction takes place. At cathode, this is the reaction going to take place. Which one? Copper plus 2 ions from the copper sulfate. Copper plus 2 ions from the copper sulfate, by gaining 2 electrons released from the zinc metal, they deposited as a copper. So this is the reaction going to take place at cathode, and this is, you know that it is the reduction, because the gain of electrons is the reduction. Now let us see the overall reaction in this Daniell cell. What is the overall reaction? This is the overall reaction going to take place. Zn by losing electrons, Zn by losing electron converted into Zn+2, Cu+2 attracts that, gains that electrons, and they converted into copper solid, and what we will get? Zn+2 ions we will get. This is the overall reaction going to take place in the Daniell cell. Now, what is the importance of the salt bridge and how the electricity is generated? Let us see. Here, because of oxidation of zinc metal, the electron density increases more on the zinc rod, and the electron density difference is generated. Here more electron density is there, and at the same time in this half cell the electron density is less. There is a electron deficiency is there at a copper rod. That's why it should be represented with positive electrode or positive sign, because less electron deficiency. So because of high electron density, the electrons moves from zinc electrode to copper electrode. And at copper electrode, what happening? At copper electrode, Cu plus 2 ions have more tendency to gain the electrons, and they deposited as a copper rod, copper solid we will get. When the time passes, the weight of the zinc metal decreases, the weight of the copper metal increases. Now what is the importance of the salt bridge? See, when the time passes in the solution, in ZnSO4 solution, which ions concentration increases? In the solution, Zn plus 2 ions concentration increases. So in left side, Zn plus 2 ions concentration increases, and right side, which ions concentration increases? SO4 minus 2 ions concentration increases. When the positive ions positive charge in the solution increases, this solution get positive charge and this solution get a negative charge. So therefore some potential differences arise in the solution. This potential difference cannot allow the flow of electrons. So what happened? Because of this potential difference, electron flow does not take place, means we will not get the electricity, we can't produce electricity. So that's why we have to neutralize this solution. For neutralization purpose, what we are using? Salt bridge we are using. Now let us see what is the use of salt bridge. Actually salt bridge allows which ions in the left side solution and which ions in the right side solution. Look at here, left side, which ions concentration is increasing? Zn plus 2 ions concentration is increasing. Right side, SO4 minus 2 ions concentration is increasing. Now the salt bridge allows which ions into the left side solution? For one Zn plus 2 ion, it allows, suppose it allows 2 Cl minus ions, and in the right side it allows, for one SO4 minus 2 ion, it allows 2 K plus ions. So whenever 2 Cl minus ions are entered into the solution, plus 2 minus 2 became neutral. Here also plus 2 minus 2 became neutral, and we can keep the solution, these two solutions, in the neutral situation. Then what happens? Continuously the flow of electrons takes place. That is the importance of the salt bridge. Here salt bridge, suppose if it is made up of KCl, then it is going to allow what? Cl minus ions towards to this cell and K plus ions towards to this cell. So that is the importance of the salt bridge. It makes neutrality in the solutions. That is the importance. And while we are selecting a electrolyte, whatever the electrolyte used in the salt bridge, it must possess one property. What is that? Its mobility. The mobility of cation must be equal to mobility of cation, suppose K plus, must be equal to mobility of Cl minus. So this is the important point we should remember while we are selecting a electrolyte, inert electrolyte in salt bridge. We should consider their mobilities. The cation and anion should have same mobilities. So this is the importance of the salt bridge. Now let us see cell representation of the Daniell cell. How we are going to represent the cell? To represent the cell, we have to follow some rules. Okay, cell representation. First of all, if you wanted to represent any cell, we have to write anode left side, negative electrode, and this anode should be separated with the salt bridge. This double vertical line is indicating what? it is indicating presence of salt bridge, and we should write right side cathode, positive electrode. Now in this cell what happened? At anode, Zn metal, Zn solid is converted into Zn plus 2 ion, Zn plus 2. If we know the concentration, we should keep the concentration within the bracket. It is what? Metal, this is the metal ion. Metal and metal ion both are separated with the help of what? This is the metal and metal ion, both are separated with the help of a vertical line. Then next one, here double vertical line, it indicates what? It indicates presence of salt bridge. And next one, Cu plus 2. Cu plus 2 ions, their concentration is 1 molar and they converted into Cu. So this is the way of representation of the cell. At anode side, how we are representing? Like this we are representing. Metal ion is separated with the vertical line, and what we are representing? Metal we are representing. And so whatever the electrons are going to released by the zinc metal, they travel from the external wire and they enter into cathode. Here the continuously Cu plus 2 ions gains the electrons and they deposited as the on the surface of the copper rod. And how is the direction of the current? You know, the direction of current is from copper rod to zinc rod. The flow of current is always from cathode to anode. The flow of electrons is from anode to cathode. So this is the construction and working of Daniell cell. Okay, per suppose they given one more equation, one more cell they given, then how we have to write the cell representation, cell reaction? They given in the examination what? In examination they given cell representation, then how we have to write its overall reaction? Let us see one example for that purpose. Per suppose we have the cell representation like this. Cu is converted into Cu plus 2, Cu plus 2 aqueous. It is separated with the help of double vertical line. It indicates salt bridge. Next to Ag plus ions, so aqueous Ag plus ions, they converted into Ag. Like this cell representation they given. How we have to write the overall reaction for this? Actually, just you see this side, whatever the left side is there, that is actually what? That is anode. That is the anode, negative electrode. Next to right side, whatever the cell is there, whatever the half cell is there, that is what? Cathode. It is represented with positive electrode. Now so at anode what happens? At anode oxidation is going to take place, means copper is converted into copper plus 2, and silver is Ag plus is converted into by loss of 2 electrons. Now at cathode what happens? This is the reaction going to take place at cathode. Ag plus by gaining electrons they converted into Ag. So here what? To make the charges balance, to make the equal electrons, we should multiply this equation with 2, then 2 electrons cancel, then what we will get? We will get this overall reaction, Cu plus 2Ag plus Cu plus 2 plus 2Ag. This is the overall reaction for this type of cell. Actually this is a redox reaction. In the redox reaction, the electrons movement takes place. Because of that movement of electrons in the Daniell cell, electricity is generated. So this is about the construction and working of Daniell cell. Actually electrode potential and cell potential. In the next class, I will discuss about the electrode potential and cell potential. Thank you for watching this video.